reflection passes through the what? Passes parallel to a principal axis. Can I wipe it?
No.
Please be faster about it.
Yes, it did.
Because I don't want to start drawing new principal axis and start measuring. If not, I'll just draw them one after the other. Anyways, let me draw another one. There's nothing much difference when it comes to production and the structure of plane mirrors, when you compare it with curved mirrors, right? Or negative.
Yes, sir.
Just as the name implies, when you look at curved or spherical mirror, it means that this glass we are talking about now has to be a spherical glass. Am I communicating?
Yes.
Let's say you have something like this. Look at the board. You have something like this. Are you with me? Now, once, depending on the portion of this sphere, I get coated with silver. Am I communicating? Once I coat the outer part of this guy, of this glass, isn't it? It turns to a mirror. Am I communicating? But at this point, it's no more plane, right? It is what? It's curved, isn't it? So once I coat this outer part, what happens? It means that the inner part here will become a reflective surface. Am I communicating?
Yeah.
Then if I coat the inner part, say from here, are you with me? It means that this inner part, alright, I just coated it into what? Silver. It means I've also formed a what? A mirror, but also what? Curved what? Mirror, isn't it? So here we are looking at what? Mirrors that are curved in motion. Am I communicating? So since I've coated the inner part of this mirror at this side will be the reflective surface. Am I communicating? And once light falls on this guy, I get to my point. You find out that the light will be diverging. Am I communicating? Due to the fact that the reflective surface is caved towards in or outward, depending on how you want to describe it, right? So once light falls here, it will be diverging. Am I communicating? But if light falls in here, I get to my point. It will be what? It will be converging. So here we are looking at what reflective surface, in which light is being what? Is being brought together. Am I communicating? Is being converged. When you're looking at what? The curved what? The inward curved mirrors. Am I communicating? So once the inner part becomes the reflective surface, this guy will be what? Converging light waves. We are looking at mirrors and not lens. Are we together? Sit down. We are looking at what? Mirrors and not what? Lens. Alright? So here, as far as I'm concerned, I have two types of what? Curved or spherical mirrors, isn't it?
Yeah.
That's what I see. There are two types now, right?
Yeah.
Good. Number one, from here is what?
Convex.
This guy is what? Convex mirror. Or concave diverging mirror. Then here I have what? Concave mirror. Or what? Converging mirror. Isn't it? So it means that outside here is our reflective surface. Reflective surface. Isn't it?
Yeah.
Then outside here, inside here, isn't it? Yeah. Okay. Inside here is what? A reflective surface. So for concave mirror, the inside is the reflective surface. Am I communicating?
Yeah.
For convex mirror, the outside is what? A reflective surface. Is that understood?
Yeah.
Is that understood?
Yeah.
Good. So if this is the case, this is what we have in our mind now. We are looking at this kind of mirror. So we are going to be placing objects on these two mirrors. Am I communicating? And know how images will be formed on them. Am I communicating? Are we together? So, but the way images are formed on the plane mirror, this plane mirror, isn't it?
Yes.
It's not the way images are formed on the what? On the curved mirrors. Are you getting my point? So, how do images form on the plane mirror? Let's look at it. Okay? Let's look at it. So, when someone asks you to define a curved mirror, it's simple. It's nothing but a spherical or curved surface, okay, in which either the inner part or the outer part of the material is what is coated. Okay, so if the inner part is coated, then the outer part is becoming reflective surface, which is convex. Then if the inner part, if the outer part is coated, the inner part will become the what? The concave or the what? Converging what? Mirror. Isn't it? Good. So, how do we form images on this mirror? I want to start with concave mirror. Do you know what? The properties, okay, of images formed on anything diverging lens, diverging mirror, okay, are just the same. They have the same properties, so we don't have problem there. Am I communicating? So where we have problem is on converging mirror or converging what lens. You're going to see it when we're looking at lens. Am I communicating? But we're looking at just mirror for now. So if we are looking at curved mirrors, there are 4 things that are very, very paramount important. Now, what are the 4 things? You found out that when you come to plane mirrors, okay, there is nothing like principal focus. There is nothing like optical center, for instance, okay. The optical center, of course, is seen in lens, okay, but there isn't like optical center for what? For plane mirrors. There is nothing like what? The radius of the curvature as case may be. There isn't like what? The pole, isn't it? There isn't like what principal was axis, isn't it? But when it comes to curved mirrors or lens, as case may be, okay, we have all these things. So what are they? You know, I'm not going to be doing it, you know, separately. I'm going to be forming images immediately, and with that, you'll be able to explain what those analogies represent. Am I communicating? Good. Now, whenever you have an object which is being placed in front of a concave mirror. I'm using concave mirror for now, isn't it? Yeah. The object is going to be standing on what? On the principal axis. Do you get the point again? So this is our what? Principal axis. Alright? Now, from here to here is our principal axis. So number 1, we have what? Principal axis. Good. Then number 2, if this is concave, right? Yeah. So if I'm placing this guy on a concave mirror, I'm going to have something like this. True or false? Now the truth of the matter is that our diagram might not actually give us an exact images due to the fact that we might have a Flowers error or mechanical errors. Alright, I'm not using my pair of compass, I'm not using protractor, and of course, you know, I'm not drawing an arc, isn't it? I'm just, you know, forming. Alright? So, but I'll try to make sure that we have something, you know, better. Alright, communicating? Yeah. We have something better. So, if this is an arc, oh, it's too small. Okay, let me have it like this. No. Look at the ball. Look at the ball. At this point, what do you call it? Huh? This is known as the pole. Let me just grab the pole. Then you will use your ruler, okay, and measure out 3 centimeters from the pole. Are you with me?
Yeah.
Are you listening? But if you don't do it like that, you're going to feel you might form whatever you want to form, but the characteristics will be, will be wrong. Okay, the concept of the image you're going to form will be wrong because you did not draw the concept diagram proper. Am I communicating? Good. So 3 centimeters from here, let me map out here as 3 centimeters. Okay. So what do I have here? The focus. The principal focus. Then we are going to still map out from here to here another 3 centimeters. Am I communicating? For me on board, what I'm doing is I'm just trying to make sure that the length I give from here to here will be the length I'm going to give from here to here. That's what I'm doing. All right. I'm not using any measurements too, isn't it? So I'm going to have it from here to here. I think it's. So what do I have here? So I have what? C here, the curvature, isn't it? The center of curvature. Are you with me? Are you with me?
Yeah.
Now, there are 2 lengths here, isn't it? Or 2 distances. One is distance between center of curvature and the principal focus, and the principal focus to the what? Oh, isn't it? 2 of them, this pair of lengths should be equal to each other. If you do not do it that way, automatically you're going to fail your image being formed. Now, after this thing being formed, now I want to give you the rules which you are going to be using, okay? So that you will have to grab the properties of the image is formed. Am I communicating? Now, the one rule is this: if ray of light passes parallel, am I communicating? If the ray of light passes parallel to the what? Principal axis, this ray, which is incident ray, is passing parallel to the what? To the principal axis. Am I communicating? If it passes parallel to its principal axis, where is it going to hit? It will hit this what? Spherical what? Mirror. Am I communicating? Now I said, if the ray of light from the head, okay, we don't calculate from the tail or from the leg, okay. The only thing for you to get the, let me not go there for now anyway. So the ray of light passing through or passing parallel, okay, to the principal axis after reflection, because once the guy hits here, it will reflect. Am I communicating?
Yeah.
After reflection, we'll pass through the principal focus. Write it down. Make sure you write the whole down. We'll pass through the what? The principal what? Focus. Am I communicating?
Yeah.
Okay. Sorry about that. I don't want to have the body diagram here. Yeah. So if you pass through the what? The principal what? Focus. This reward is very simple, isn't it? Look at this ray. The reflected ray is actually ray, not complicated, isn't it? Because we coated the outside. So the rays here will be converging. And converging rays will be what? Will be real. Real, but what? Real, but what? Real, but what? Inverted. But virtual, but what? Upright, isn't it? So, this is what reward. Have you done drawing reward? This reward. If I were you, I will draw it separately, one after the other. Okay? Because I'm going to wipe this one. I'm drawing two. This reward. This one. In reward. The root 2. Are you with me? Root 2 will be like God. Ray of light. Are you there? Okay. Root 2, ray of light passing through. The principal focus. Everything is in God. Ray of light passing through the principal focus. After reflection, moves parallel to the principal axis. Am I communicating? I want you to tell me what you observe between reward and root 2. What do you observe? Between reward and root 2. What do you observe?
Like opposite. It's like opposite.
Is what?
The rays.
That's what I'm saying. What do you observe between reward and root 2?
The rays are opposite.
Are opposite, isn't it? What happened in root 2 is actually the opposite of what happened in reward. In reward, the ray was moving through the what? Parallel with the principal axis. After hitting this guy, we go through the what? Principal focus, isn't it? But here, if the ray was, is being incidented on the mirror, on the converging mirror, through the principal focus, after hitting this guy, it will reflect, right? So after reflection, it will pass back through the what? The principal focus. Very, very important. This is rule 2. The other one is rule 2. I'll give you 4 rules. Are you with me? Ray of light passing through the principal focus. After reflection, ray of light passing through the principal focus, after reflection, moves parallel with the principal axis. After reflection, you must put that after reflection. Passes through the what? Passes parallel to the principal axis. Can I wipe it?
No.
Please be faster about it. Because I don't want to start drawing new principal axis and start measuring. If not, I'll just draw them one after the other. Anyways, let me draw another one here. So I have a curved mirror from here, pole, from here, center of curvature, isn't it?
Yeah.
Good. Then here is my object size. As case may be my object, isn't it? So let me have so that we can be using both of them, right? So the third one is that a ray of light passing through the center of curvature. Am I communicating?
Yeah.
After reflection, moves back through the center of curvature. Look at the board. This is what I have here. So this ray actually passed through the center of curvature, right? So after hitting here, due to the fact that I will not explain much there, but due to the fact that this reflection is actually going to form a normal perpendicular, am I communicating? The resultant will still be moving on the what? On the center of curvature perfectly. Am I communicating?
Yeah.
Are we together? So the third rule is that what? When a ray of light is centered on the converging mirror, okay, through the center of curvature, after reflection, will pass back through the center of curvature. So the incident ray and what? A reflective or reflected ray will meet. Am I communicating? Are we together?
Yes, sir.
Now, the fourth rule. Now, this fourth rule, please, I will advise you not to be using the fourth rule. Okay, except if and only if the fourth rule is what is needed. You know why? You might not be able to, to measure out you might not be able to be using protractor in your exam. Say for example, those of us that are writing JAMB, you will not be able to be using protractor during your JAMB exam, isn't it? And if you're using protractor during JAMB exam, automatically, if you use the fourth rule, okay, which is actually the rule that supports the first law of reflection. Am I communicating? That or the second law of reflection actually, that the angle of incidence is equal to angle of what? Reflected ray. Am I communicating? So if you use that word, you might not be able to measure out the two angles with a protractor because you don't have protractor in that exam. Am I communicating? Am I communicating? So from these four rules we are going to be giving the last one right now, okay, you will find out that for you to be able to form an image, you are going to be using just 2 out of the 4. Am I communicating? So any 2 that suits you, use it. While using the 2, I will show you, as a class, just as soon as possible. Alright? Now the 4th rule is that a ray of light that passes through, am I communicating? The pole. If there's something like principal pole, that passes through the pole, this is it, right?
Yeah.
The ray of light that passes through the pole after reflection, a ray of light that passes through the pole after reflection, moves back on the opposite side with the same angle. Moves back on the opposite side or reflect back on the opposite side with the same angle. With the same angle. So what I mean by that? Alright? Now, why did this happen first? See why it happens. Once this wave hits this guy, am I communicating? The ray will meet this area as normal. It will meet it as normal. I get to my point. It will meet it the way your image meets a plane mirror. I get to my point. So once it meets that way, it will behave the same way. What's it called? A plane mirror behaves. Am I communicating?
Yes, sir.
Now, the 2 laws we have in reflection is number 1, that's what? That incident ray, the reflected ray,
and the
normal, isn't it? At the point of what? Incidence, isn't it? All lies on the same plane. All lies on the same plane. So, see the plane here now. Are you with me?
Yeah.
The incident ray, the reflected waves, this is normal, okay? So that's why when the incident ray touches this guy, it's touching the normal. Am I communicating? So it's just have to bounce back purely. If the angle of incidence, which is I, is 45 degrees, it will reflect back on the opposite side with what? Angle of reflection of what? 45 degrees. Am I communicating? Are you getting my point? Are you getting my point?
Yes.
These are the 4 rules. So, but this 4th one, please, for me, I advise you not to be using it if you don't have protractor in that exam. For you that are writing the egg, of course, you can use the 1st rule because you can measure into protractor. Am I communicating? Am I communicating?
Yes, sir.
So, how many rules do you have now? 4 rules. So, if I want to form an image now, it will be so easier for me. See what I'm going to do. Since I know the 4 rules, can I wipe this guy?
Yes, sir.
I want to wipe everything on this 4th rule. Okay, should I wipe everything? No. I had to have everything. I see drawing this. Huh? Let me use this side. I like using this side, number one. This side, it should be as though I'm doing less. So let's use this side. For me, do you have a long ruler here? Even if it's 10 centimeter, as case may be. Any ruler here? Anywhere. Okay? Anyway. Okay, let me have this. I think I'm trying straight now. So, if this is our converging mirror, how it will be, and this is our pole, then this is our principal focus, and this is center of curvature. Automatically, our first position, the first image you want to form will be when the object is beyond what? The center of curvature. I've written it down. We are forming images now. Formation of what? Images. Formation of images using concave mirrors or mirror. Isn't it?
Yeah.
So if this is you place yourself in front of the reflective surface of what? Of a concave mirror. And this arrow shows that this is your head. Am I communicating? Then this is your what? Your leg. Are you with me?
Yes, sir.
Good. I say it's you, not me. Isn't it? This is what? You. Now, if you want to form, look at your image when you are in front of this mirror. This guy is, put there, alright, at the back part. So we're going to use two rules. So tell me the rules you want us to use.
The first
One, I think one will go very well. This guy will touch here, isn't it?
It is.
Then what? Pass through this guy, isn't it?
Yes, sir.
Let me know this guy here. Let me use it inside. Okay. Like I said, we are going to be using what? 2 out of what? 3, isn't it? The first one I said you should just leave it because of what? Inefficiency or because of error. Am I communicating? Good. So, which other one do you think we should use?
The second one.
The second one. The second one, if this guy moves towards this is what I just did. You know, he didn't touch this guy. So even though I'm going to form an image, but somehow my image might not carry the characteristics it's meant to carry. The problem is always on the size of the image. Am I communicating? I really know that this image will be real. Am I communicating? Yeah, real and what? Inverted. Isn't it? I really know because it's converging, right? But the size might not be what? The size might be diminished, but due to your drawing, it might be what? Magnified. Due to your drawing, it might be what? What is it called? On the same size. And that is where the problem lies. You see it? So the measurement or using ruler or a measuring tool, the only place is important is not on the position. You know where it is being. Yeah, somehow positioning can also be affected. Am I communicating? If I didn't draw it very well, if I should move this line towards this direction now, I get to my point.
Yeah.
My image will not form where it's going to form. It will form at another position. Do you see why? What is it called? Using mathematical set or apparatus to draw this is very, very important. Am I communicating?
Yes,
so, but that is that notwithstanding, we are going to still, do what we are meant to do. The only thing is that what we must learn how to draw this. All right. So, okay. I think I should go with third rule. okay, as a using it. If I use third rule, if this guy moves here, after reflection, it will still go back, isn't it?
Yeah.
Of course, the second one can still work, you know, but the point there is that, you know, drawing and all that. So let me just use this one. Is understood? So what is the image formed? Your image is formed where the two reflected rays intersect. Am I communicating?
Yes, sir.
So what they intersect?
Between the center of curvature and the foci.
So which means, since I am seeing my rays, my reflected rays, it's not with dotted line, isn't it? So this is an actual ray. So this ray actually touches the image. Am I communicating? That's what makes the image to be a real one. Once light has cut across the image, that image is a real image. But if what is it called? Light did not touch or did not cut across the image, is a what? Is a virtual image. So this is what real, isn't it?
Yeah.
So the properties of this image beyond
C.
we are looking at beyond C, isn't it? Okay,
Yeah.
image beyond the C, center of curvature, is that number one. The properties.
It is real.
This guy is what? Real.
Real.
Real and what?
Real and
Inverted, isn't it?
Yeah.
So here, this guy, the head, will turn upside down, right?
yeah.
Am I communicating?
Yeah.
Do you get the point now?
Yeah.
So, number two, where is this from the position?
Between C
Between
and
center of
A.
curvature and what? F. It formed between what? C
C and A.
and the principal was focus. Number three,
It is diminished.
what is the size?
Smaller in size.
Is it the same thing with the object size? No. So it's small, right? So this is diminished. Diminished image. These are three things we are looking out for whenever we are forming images. Are we together? So since I'm able to form beyond C, okay, I'm going to move forward. Not me actually, but this you, isn't it? We are going to move what? Forward. Let's know the properties of image that will be formed when you come closer to the what? To the concave, I mean, in front of the what? Concave what layer. Am I communicating? Good. Can I write this one?
Yes, sir.
Any question?
No.
So I have to move this guy from here. Okay, let me go first. Okay, so where should I go to? Should I come closer to C or I should go to C straight up?
C.
At C, isn't it? Because if I go close to C, I see the first is beyond C, still beyond C,
Yeah.
isn't it? So you are going to move to what? To C. This is where you're standing now, isn't it? So what should we use? I think the first one can still go.
Yeah.
The first rule can go. After eating this guy, we'll pass through this, isn't it? Isn't it?
Yeah.
Can the third rule go? You know, the third rule went, it was able to use it when it forming the first one, right? You cannot pass through the C again, isn't it? Because it's standing on C. Light cannot pass through the C. Am I communicating?
Yeah.
So the second rule will go, right?
Yes.
So you guys will pass through
F.
the principal focus. After reflection, we do what? We pass parallel to the what? Principal axis. Are you seeing something?
Yeah.
Properties of image is formed here. Properties of image is formed here. Look at the point. One is that it's real.
It is real.
Yeah, since it's real, this guy should be what? Inverted. Am I communicating? Am I communicating?
Yeah.
Good. Two, where did this guy form?
At C.
Image forms at C. You see it.
Yeah.
But when it was beyond C, when the object was beyond C, it was formed in between C and F. But now it's on C. The image will form on C. Are we together?
Yeah.
Am I communicating? Am I communicating?
Yeah.
Good. And at the same time, you will find out that, let's look at the size. What do you think?
It's the same.
The same size, isn't it?
Yeah.
The image size is same with what?
And the object size.
The object size. Are we together? We are done with what? We are looking at B, sorry. So this is at C, so B is what? At center of origin, at C. Alright?
Yeah.
Are we together? So I'm going to get the third one now.
Inverted. It's inverted.
Is what?
Image.
Oh, sorry. Yeah, it's inverted. You mean that I understand what we're doing? I see. It's inverted, yeah. That's correct. Alright? But here is not straight, you know. But I'm trying. It's not easy. Can you draw?
Yeah.
You want to come and draw?
No.
Can you draw? Yeah, you want to come and draw? No. So let's go to the.
Between.
So you want to move between from C to what? In between C and F,
Yeah.
isn't it? Then after which you look at what? F.
F.
Then you move into what? Between F and what? P.
P.
Can you stay at P?
No.
What are you doing there? You can stay at P. If you stay at P, you like to know the following on the classes, isn't it? But let's try. But you can stay closer to P, isn't it? So let's look at it. Which I can draw another one. Okay. So we have F, we have C, isn't it? Isn't it?
It is.
So where are we moving at now?
Between C and F.
So which one will go?
The first row will go. And the
These are not straight. These are not straight. But we move like that. Okay? Which one will also go?
the last one. Second.
I'm seeing something. Are you there?
Yeah.
So, what do you have here? The properties, isn't it?
Yeah.
Let's look
It
at
is
the
real and
properties
inverted.
at between C and F. At between C and F, isn't it? So properties here. Number one
It is real and inverted.
is real and inverted, which means I come here and have this guy, right? With the form
Beyond C.
beyond C. Okay? Image from beyond C, right?
Yeah.
Number three, which other one?
Large.
Is what? Magnified. It is magnified or enlarged, isn't it?
Yeah.
Magnified image. Is understood?
Yeah.
Can we go to focus?
Yeah.
Are you not drawing it?
Yeah.
So I believe you see how we are forming the image, and then we look at it, we find out that that guy is not difficult. Or is it difficult?
No.
Good. So we're moving to what?
Principal focus. Principal focus.
Should I go ahead?
Yes.
So I'm still drawing this. Please, I think you should be drawing it faster. Listing the way you draw, yeah, so that you're able to move ahead.
Okay, the next one is
I think you should drop from your level right now. At air. You are coming to air. At air. You know, if you use your ruler on your, what's it called, on your notebook, you will get a sharper this thing diagram than me, okay? Because I also use using the ball, alright? So if you use your ruler, even though you are not even using pure measurements, okay, like measuring proper, you will get a sharper and clearer image, more understandable one, alright? I'm looking at what some of you are drawing. You guys are trying. You guys are trying. You draw that one on an interview. You just use that job. You lose it, and you know you lost the job before you even enter. I'm not talking to everybody. Now look at the job. I'm not talking to anybody. I'm just saying what I saw from somewhere. So where are we going to now?
At air.
So you're standing on Earth now.
Yes.
This is promise on Earth. Now, which one will go?
The fourth room.
Fourth. The first room.
Fourth.
The fourth one.
Yeah.
Who is in the fourth one? How is it projected here?
Okay.
The first room can go now.
Okay, yes.
It can go first. You know, it's not trying to pass through the principal focus. It can pass through the head from here. Parallel. Isn't it? Then move through the what? The principal focus. Isn't it? Okay. So which other one can go? What one can not go?
The third one cannot go. That is incident 3, passing through the principal focus.
Okay, so this one cannot go. Are you sure?
Let's just use that first rule again. If you draw it from the foot of that,
From here.
from the foot of the object, yeah.
From here. You don't draw from the foot. You draw from the head. So, but the fourth one can go.
Yeah.
Now don't use the fourth one. Why do you think that this one cannot go?
Because the incident 3 cannot go back.
If this guy go to the pole, isn't it?
Yeah.
It will do what?
Go parallel.
Isn't it?
Yeah.
No, looking at the pole. So, something happened there. I want to draw it to this ball ends. No? Now, the two rays, or the two reflected rays, could not meet, for what I'm saying, alright?
Yeah.
Isn't it? They could not meet, they are parallel. Isn't it? We image before. Yes.
Yeah.
Image before.
At infinity.
At infinity. God bless you. Now the properties To start with, number 1.
It is real.
Oh.
If the image is formed at all, it will be real and
If it's formed at all. Maybe not formed at all, it will be virtual and upright. Okay. The image is formed, but formed at infinity. That's what I'm trying to say. Okay? This image is real and what? Inverted. This image is highly magnified. Are we together?
yeah.
Good. As you can see now, the number 3 is that the image is formed at what?
Infinity.
To infinity. Are we okay?
Yeah.
Is that understood? Huh?
Yes, sir.
Yeah. Where is infinity? You asked me what's the meaning of infinity.
Continue.
Do you get it?
Yeah.
Okay. So where again are we moving to?
Between B, F and B.
Between what?
F and C.
Between F and P. Between F and P. Now, please get me a marker. Fill these 2 markers. Get me a first. Okay, let's look at between F at F. Sorry. Between F and P. Isn't it?
Yeah.
Now look at the board. Now thank God we were able to. You know, I was trying to use this C when I was forming this image, but thank God we were able to use the first row. But this last one, I'm going to use the C. So don't be confused, alright? I will tell you why I can use C. So let me place it here. Between F and P. Then welcome to close for now. Are we together? Are we together? So which one will go? Yeah? The fourth rule. Okay. This is right? Okay. Which one will go? Huh? Not that one. Can this one go? Why? Now, look at the board. If this guy, if light falls here, that is my point. It will seem as though it's moving towards this guy. Again, or if light falls parallel with the principal axis, it will look as though it's passing across the principal focus. Now, you notice something from this diagram. You know, when you look at it, you think that the diagram we have now is the same thing with the diagram we had when it was at F. It's not true. One, let me forget about this one. Let me use this first one. I can use these two. I can use these two. I can use these two. I can use when it's moving across this and this. Okay? I can use when it's moving across this and this. Anyone I want to use. But the point there is, when you're drawing with your book, you find out that as you try to measure that line straight, you will find out that this reflected ray will be divergent. They are not actually being parallel with each other. In the other one, you will see it that this guy is moving straight. But in this one, how this one is concerned, you are able to measure from here to here, and from here to here was equal to from here to here. Look at my diagram. I'm even seeing it now. The distance between here to here, F and E, is not the same thing with C and F. This one is bigger. This one is smaller. Isn't it? But even at that, I could still see my ray diverging from here. Am I communicating? So anyone I want to use, let me use this one and the other one. So let me remove the second row. I mean the first row, isn't it? Let me use the fourth row and the third row. Is that the third row? Yeah, third and fourth row. Let me use both of them. So I'm going to remove this one. I don't know if you're getting my point. You found out that if I draw this line as it's moving, this one will move like this. It will be diverging. I'm not communicating. So if it's going to be diverging, automatically the image that will be formed will form what? Behind the mirror. I told you now, it will be virtual. In divergent, the image will become what? Virtual. And what? Upright. In convergent, the image will become what? Real. And what? Am I communicating? So, since from my reflected rays, my reflected rays are what? Are divergent. They are what? Divergent. Am I communicating? Automatically, my images will be formed for what? Here. I get to my point. So, these two, I believe I'm not using three. Okay? Yeah. Then I'm going to be having this one. Are we together? Then this one will go up to meet it up there. I get to my point. So the reflected ray will seem as though they are coming behind the mirror, which will make this image to become what? Upright. And what? Virtual. And what? Highly magnified. And what again? Formed behind the mirror. Is understood? Yes. That's why you can use your concave mirror as your shaving mirror. Even though that normally concave mirror is meant to be what? Inverted, right? Yeah. Isn't it? You cannot, you don't want to shave your beard and you are seeing your face upside down. Am I communicating? So the concave mirror that we use for shaving mirrors, okay, were actually gotten from what? From this mirror, when the mirror always positions the object at what? At between focus and what? And the goal. Therefore, making your face to become what? Larger. Then two, still keeping your face what? Erect. Am I communicating? It's very important you note this application. It's still on converging mirror, but yet we are seeing it as upright. I get my point. So the last position, the last location of the image which we just finished doing now, okay, is actually going to be a virtual image. Other than other one that you want real, it must be what? Virtual and what? Upright. I get my point. And the usage is on this what? On this uprightness or the erectness of what? Of image, and also what? The magnification of the image. That's why we are able to use it as what? As a shaving what? Mirror. Am I communicating?
Yeah.
So the properties. Number one, tell me.
Virtual and upright.
Virtual and upright.
Highly
Number two.
magnified.
Highly magnified.
Form behind the mirror.
Image is formed.
That's changed in resources. That's changed in
Are you there?
Yeah.
Am I communicating? So why do we form this? Because we saw our reflected rays diverging. So since they are diverging, they cannot be able to form image in front of the mirror. They will go to the back and converge. Am I communicating? Do you get the point? Yeah. Now someone can ask, where did the image form when they are said to be formed at infinity? You are the only one, and your ancestors are the one that know where it's being formed. Because the image, that guy, that ray, those two rays are just moving parallel. Am I communicating? It's only them that knows where they are from. So since we don't know, we call it infinity. Am I communicating? But for this one, since we are looking at it diverging, they start behaving as a convex mirror. You see it now? So they will go to the back and form the image. And as such, make the image to the wall, to be magnified, and make it to the wall, to be upright. So it is used as well as shading mirror. Are we together? Are we together? At this point in time, I want us to end this one here and start with what? With convex mirror. Am I communicating? So you are going to be watching out for the next episode that's basically the next class on core mirrors. Am I communicating? So that also, yeah.